Hey student people, we're going to do our review set and I'm going to do this on the fly, which means it probably won't work. That's okay too. You can watch me do it. You can watch me not work. So I'm using my Mac, but it's pretty much the same um, as when you use your Windows. That's okay too. So in problem one, we're looking to see at salaries to see if men and women are paid about the same for comparable work. Uh, so we have our data set in gender.txt. The dollar amounts are in thousands of dollars. So if you see something like 63, that really means $63,000. We took random samples from men, random samples from women, and these are both purchasing managers. And we can think of this as a two population independent sample. We want to test the claim that the mean men's salaries are greater than the mean women's salaries and let alpha equal 0.05. Okay, so we're going to get the data set in. So we're going to have read.table file equals gender. Oops, can't spell. Header equals true. Okay, and I just like to look at my data like you always know. So response variable and a sex variable. Sorry, it's just men and women, not a frequency. And we're going to have t.test, and it's going to be resp tilde sex, and it's going to be data equals gender. Now, remember that we want to do the alt is greater than. Oops. Okay. So there you have it. All right. Nothing very interesting. And if we're going to do our test of hypothesis, so we have, I'm just going to do it on here. HO is mu1 less than or equal to mu2 versus mu1, mu1 greater than mu2. And our p-value is, where is it? Oh, sorry, 0.00356. And our if then is if p is greater than alpha, you know the rest. And we will reject. So in the purchasing world, apparently men are still making more than women. Okay, good. All right, problem 2. So in this one, the adolescent females are more likely to deliver low birth weight babies than adult females. So we're looking at a study in which the independent variables is the age of the mother. The dependent variable is the weight of the baby. And notice it's going to be in grams. So don't panic when you see these funny numbers. They're like 2,000 and 2,500 and stuff. It's in grams. The data are in the file birth.txt. Find the least, that should be least, or excuse me, squares, not squares. Regression equation. If the young lady is 16, what do we expect her baby to weigh? Okay. So, we're going to have birth is read.table file equals, Oh, there's my equals. Birth dot tech and header equals true. And let's just look at this. And X is the age of the mother, and Y is the birth weight in grams of the babies. Okay, so we're going to create a linear model object. So we're going to call this birth.lm. And again, that's just an arbitrary name. Don't get too choked up over it. It's just a good habit to get into. LM, create a linear model object, is Y tilde X. So you do the dependent as a function of the independent. Data equals birth. And then you just do summary birth.lm. Okay, good. And if you run down the coefficients column, that's going to give you your least squares regression coefficients. So you're going to have something like, I can't put the hat on the y, but you'll have y hat is equal to minus 1163.45 plus 245.15 x. That's your equation. And then if the young lady is 16, how much will her baby weigh? So in that case, we're going to let x equal to 16. And we'll just plug in the 16 where the x's are. So I'm going to actually just let r do this. I'm going to have minus 1163.45 plus 245.15 times 16, and it's 2758.95. So that's all you have to do. Okay, that's problem 2. Then in problem 3, we are interested in the calcium content of wheat in storage over time. We select 4 different time periods and have them represent the treatments. Each treatment has 6 observations. This is a completely randomized design, and the data are in the file serial.txt. So essentially, you're going to look at the 4 different time periods: 0 months, 2 months, 4 months, and 6 months, and measure the calcium in the serial. Okay, and we're interested in seeing is there a difference in the treatments representing the time amounts. Okay, so you're not applying them in the sense that you're applying like a construct on there, but as time passes, that is your treatment. Okay, so this is called serial, and we're going to bring in the data file, read.table file equals serial. And str serial. Okay, so we have 4 levels representing the time periods and the response variable representing the amount of calcium. Okay, so I'm going to create an ANOVA object in this one. It's completely randomized design, or one-way ANOVA. So I'm going to have serial.AOV is equal to, or assigns AOV of RESP tilde TRT, and I'm using the data set serial. Now I use summary.AOV of serial, .AOV. And then while I'm here, I'll just go ahead and use the Tukey HSD on summer, excuse my fault, on serial.AOV. And I'll do the plot in a minute. Okay, so when I want to do the test of hypotheses, I will do something like HO. So there's 4 time periods. It's going to be mu1 equals mu2 equal mu3 equal mu4 versus, having a tough time, not all mu sub I are equal. Okay, then the p-value, 0.00298. And you know, if then whatever. And here again, we're going to reject HO. Okay, so they're not all equal. But which ones are not equal to which other ones? Well, you can either look at the chart or you can look at a picture. Oh, let's look at a picture. That will be fun. There. Okay, now CNA looks like it might be okay, but if you look carefully, the line just barely crosses the 0 line. So it's out. DNA is good. DNB is good. Okay, for people that were asking, are they ever on the right-hand side? Here they are on the right-hand side. So DNA are different, DNB are different. So we would say D and A, D and B are different. And again, if you look back at CNA, remember I told you it looked close but not quite. And if you look at it, it's just slightly over 0.05. So it did indeed cross the line. Okay. All right. Who's ready for problem 4? Woohoo. So let's do, we have 3 software suits. And we're going to let 5 employees learn each system. And once we figure out how they learn on those, then they'll determine which one they're going to buy for the whole company. Okay? So the treatments are the 3 types of software. The employees are the blocks. So each employee is going to learn each of the software. So the data are in soft1.tech. So let's just call this soft. Okay. Read.table. File equals soft1. Okay. Header equals true. And I want to make sure that you see this. This is kind of different than what we've seen before. Okay, we have 2 variables here. Well, actually, we've seen it before. We've got your response, you've got your treatment, and you've got your block. So you've got the treatments are the 3 software kinds, and then your blocks are your 5 employees. Okay, so I use Roman numerals for them. All right, so let's put this together. I'm going to have an ANOVA object, but I'm going to set up a randomized block ANOVA object. So I have 2 variables, one for the treatment, one for the block. So I'm going to have soft.AOV is AOV, RESP, okay, tilde TRT plus block, comma, data equals soft. And then we want to look at this summary soft.aov. And finally, we're going to plot the Tukey. I think that'll be easier. It's going to be way easier. Okay, we'll come back to that in a second. Where's the commander? Okay, there's the plot. Huh, lost our commander. Well, anyhow. Alright, so for the blocks, we've got our blocks. I know what I want to do. We ran into this the other day. So we're going to do equals C 2, 1. Okay. Oh, I know, because we aren't using the R commander. That was my fault. I'm sorry. My brain just went dead. Sorry, guys and girls. Okay, so A and C are different. C and B are different. Okay. This one I'm going to pull off the printout. But we've got 2 of them here, 2 of them here, and 2 of them here. See, this is nice. You got them on both sides. So you've got 1, 2, 3, 4, 5, 6. So 6 of them are different on this one. 2 of them are different on this one. Good. Let's go back to the console. Let's go ahead and plot it out. Actually, let's lose the plot. Okay. So as promised, CNA, CNB, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 5, 4 and 5. Okay, those are the ones that are different. Oops, did we do a test? Uh-oh. I think if I remember correctly, we would reject on both of them. Just pretend we wrote them out. Make sure you write them out tomorrow. Okay, but yeah, you would reject both on treatments and on block. So there's a difference between the software suites, whatever, and there's a difference between the employees. Okay, good job.